Today we'll just finish up all these U subs. Very important section, substitution rule. It's a technique that's used over and over and over, especially through calculus 2 and calculus 3. If you have any questions about the textbook problems, please let me know because they're really good. The ones in that section are actually really good. We'll do a bunch. I thought I'd start with this guy. Evaluate the indefinite interval. No, just do a bunch of U subs. That'd be great. So you gotta integrate this. Now do you notice this isn't the fraction we can split up? Remember the one last class we split it up? Bill Raj, you came up with that idea. We split it up into two fractions. But this has a binomial on the bottom, so we can't do that, right?
Mm-hmm.
So our next idea would be, let's approach this by at least trying the substitution rule, or U sub. And they go, well, what would I let U equal to? Well, now you got powers in there, right? Exponents. I got an x squared and a 1 and an x to the first. Focus on the one that has the power higher by 1. So what do you think I should let U equal to?
1 over x squared.
Good. And not only the x squared, I'll let U equal the entire denominator. I'll let U equal the entire 1 plus x squared. So we'll go off to the side and we're like, let U equal 1 plus x squared. And this is gonna get us through this problem. Alright, du. What's the derivative?
2x dx.
2x dx. And you'll just over and over do this 3-step technique. Sometimes you can finish in 2 though, but not here. I'm gonna have to divide just the constant, right? So 1/2 du is equivalent to the x dx then. We'll just substitute. Okay, you're coming in. You're due. Down here, you're coming in. To replace the dx and the x. Okay, here, 1/2, I'll sneak it in right there. 1/2 du. That's what's going on. Well, let me write this neater. I can put the half out here, right?
Mm-hmm.
There's a u in the denominator, there's a 1 up top, and then there's a du. There's a integral 1/2 integral 1 over u du. What's the integral 1 over u though?
Natural log absolute value of u.
That's it. So these things are on, uh-oh, there's a glare going on here. I'll have to pull that down. That's not go down after a while. But does 1 over x become a natural log of x? U. Plus c, because there's no numbers, it's an indefinite integral. And don't forget, we gotta resubstitute, right? What do I put back for u?
1 plus.
You got it. Hello? You leave it like that. Now, do you know who Bob is? Bob's backup book. B-O-B for backup book, right?
Mm-hmm.
So you check Bob. Bob has this. Someone in the class is going to tell us why. This backup book. What the heck was that? A typo? No, it's not a typo. We got that, right? I've been telling you all along, we got to put these absolute value bars here.
Mm-hmm.
That's the rule in this backup book.
Because x squared is greater than 0 all the
You
time.
got it. Outstanding, both of you. They're saying, well, x squared is always what?
Greater than
No
0.
matter what x is, and this expression right here is going to be positive anyway, so you don't have to keep those bars or anywhere. And you can just solve it. Cool. So I just want to point that out. When you see that, I didn't want you to be thrown off. And why didn't they put bars here? If it was x cubed, they couldn't do it. Right? Because you can get negatives. But x squareds, x to the fourths, x to the sixths, always positive, don't put the bar. Alright, so look at that, now let me put the original down. This was 1 over, no, what was on top, x?
X over 1 plus x squared.
So the whole question, you kind of lead this course, or it might even happen right now, you go, man, when do I do u subs? Well, it's like when in doubt, try a u sub, it really is, do a substitution rule. See if you can integrate something, but if it's quite complicated or as a composite function, try a u sub, because it's the only technique we've learned, right? I mean, if it's just sine of x, we're just gonna do the integral sine of x. But then, sometimes these problems look alike. So that's why we don't just spend a day on u subs. You spend 2 class days on u subs. No? It gets a lot of time, a lot of focus. All right. That looks just like this. Doesn't require the substitution rule though. And you go, how do I do it? And we go back, we go, oh yeah, remember? What was the derivative of arctan of x? What was the derivative of inverse tan of x? 1 over 1 plus x squared. Very important to know this one. You go, oh, so I gotta really know that. I know. Very important we know that one. So sure enough, what is this?
1 over tan inverse x.
That's it. Done. Unless you want to write arctan. Here, arctan. You can write like that. Do you see what I mean? And it's through experience, it's through studying, it's through practicing, you recognize this. You go, oh yeah, that's just arctan. I know, here's another one. 4 over 1 plus x. When you agree this is another arctan,
Mm-hmm.
that's just a 4. You could take that 4 and put it out in front of here. We've been doing that all along. It's like that's 4 times the integral of 1 over 1 plus. Again, arctan, it's just 4 arctan. So, you know, not to scare you, but if you want to put parentheses on it, you get arctan of x. Or inverse tangent of x or arctan x. Cool. But that's the idea, you know, sometimes problems look alike. Plus, if you tried substitution rule, it wouldn't work. It wouldn't work. Remember that integral of the dx squared?
Mm-hmm.
So at the end of class, remind me, we gotta do that.
Okay.
Because the substitution rule doesn't work on that one. And when I couldn't assign this one to you, because there's no like x in front to make this work by the substitution rule. But if you're curious in the class, we can talk about like future approaches, other techniques you'll learn, where you can play around with that.
Last night you were saying that we're going to do some like two functions in the denominator.
That's right.
Uh,
That's exactly right. You're gonna like that one though, I know, when we do that one. Because that'll be something for Calc 2. You gotta go to Calc 2. Oh good, center class, we'll talk about that. Like, you got a way we can approach just the integral of e dx squared, because the substitution rule doesn't work. The u sub doesn't work. And we'll talk about what you do in the Calc 2 class. Alright. X over 1 plus x squared, 1 over 1 plus squared. So now I'm going to the textbook. This is number 45. Can I erase this? Alright. Can I erase that one? Alright. I want to hear your thoughts on this guy. I noticed the author put this problem in red bold-faced print. What's that mean? It's a tough one? Let's see. Just be determined. We'll get the answer. We'll figure it out. How is this from? Well, gee, 1 plus x. I'm sorry, that's not arctan. So it looks like we try u sub, right? But right off the bat, it doesn't work. I mean, I'm looking at it, look. It's okay in math to try something first and it doesn't work. It's kind of fun. You're like, oh, let me see. Can I try it? Let me see. U equals maybe 1 plus x squared. Yeah, but it doesn't fly. You go, why not? Because here I'm only going to what?
2x dx.
It's just not going to work. Look at why, because I go down here, I mean, even here, 1/2 du. I mean, I cannot, this is not gonna work out for me, cause this goofy 1+ in front's in my way. This is not working. Dang on it, I was close though. Any suggestions? You got an idea?
Could you do the denominator?
Like what?
Like u equals 1 over 1 plus x2, x squared?
Well, I tried that. It was close. See, it was close, but this part's bugging me. It's in the way.
Divide by 1 plus x numerator denominator. Divide by 1 plus x on both the sides.
Can you split it?
Oh my gosh, you nailed it. Did you hear this? Jess, great idea. Cal, great idea. You know what they said? Split it. We're gonna split this fraction. We're gonna look at this we're gonna write this as, good eye that you saw that. Do that. Plus, what's the next fraction?
Or x over 1 plus x squared.
Here, I'll put dx's on both these. If you don't want to put two different integral symbols, you don't have to. I thought I'd emphasize. Which one's the arctan?
The left one.
Alright, so that's arctan, right here. Man, great idea. That's how we attack it. You're like, oh, split it. And then which one's the u sub? This one's the, now the u sub will work. Let me just get this over here. This part, near over, will work now. Now it works. Yeah, split it. That becomes arctan. And then this becomes, here we go, let's do the u sub. Put the half here. X dx is out. Put the du. And then the 1 plus x squared gets replaced with the what?
1 over u.
Oh, that looks sloppy. Then when we split up the fraction. So what do I have here? Let me write this again. 1 over u du. And we get inverse tan plus 1/2 natural log. Put your u back, right? Don't okay, I put the u back in?
Mm-hmm.
Now, I just did 2 steps at once. I want to make sure I was okay with that. It's 1/2 natural log of u, and then I resubstituted, did my resubstitution. Is that okay with that? You only have to put 1 plus constant. Do I need the bars? No, good, yeah, because it's already positive, so I can what? Does anybody want to move this here and then make it a square root? Because of log properties? You don't have to. You know what I'm talking about, log properties? Remember you could move this? Just remember that in our 141 class? Oh yeah, you can move that here. But you don't have to. You can make that a square root of if you wanted to. Jessica, and all that?
Yeah, where did the c for the, not the bottom, at the top, when it was tan minus 1 plus c? Is it just 1 plus c because it would be constant?
You bet. You can put 2 plus c's if you wanted to.
It wouldn't matter.
It'd be, yep, and here's why. They're unknown constants.
Yeah.
They're unknown. They can be any constant available. You could even write it as, hey, a plus constant sub 1 and a plus constant sub 2, or a plus a c plus a d. You could write it that way. But we're saying, well, they're unknown, so we'll just make it what? Plus some constant c. Right? Or if you don't even like the variable c, you could use any variable. Make it a Greek variable. Do like alpha or something. Beta. We use c all the time. Everyone okay with that? Alright. Hey, try this one. Let's do an indefinite integral, and then afterwards, let's make it a definite integral.